Welcome to Episode 63, Sustainability Commitments and Strategy. In the modern economy, sustainability is more than an ethical imperative. It is a competitive advantage. Organizations that reduce waste, optimize energy use, and plan for longevity not only protect the planet, but also improve efficiency, reputation, and resilience. Google Cloud integrates sustainability directly into its business strategy, viewing environmental stewardship as inseparable from operational excellence. By embedding carbon awareness into data center design, supply chains, and software practices, Google demonstrates that sustainability strengthens innovation rather than constrains it. For businesses adopting cloud technology, this approach provides a ready-made foundation for responsible growth, where efficiency, transparency, and accountability converge to drive both environmental and financial performance. Google's commitment to carbon-free energy stands at the center of its sustainability strategy. The company has already achieved carbon neutrality and now aims to operate entirely on carbon-free energy around the clock. This means not just offsetting emissions, but matching actual consumption with clean power in every location and every hour of operation. Through long-term power purchase agreements, renewable infrastructure investment, and advanced energy analytics, Google works to decarbonize both its operations and the broader grid. For customers, this translates into an immediate reduction in the carbon footprint of workloads hosted on Google Cloud. The ambition is clear: a future where every computation, transaction, and query runs on energy that is clean by default. Data center efficiency serves as the practical foundation for reducing environmental impact. Google measures efficiency using Power Usage Effectiveness, or PUE, which compares total facility energy consumption to the energy used by computing equipment. Decades of engineering optimization have driven Google's global average PUE to industry-leading levels. Machine learning models now manage cooling dynamically, minimizing energy consumption based on real-time conditions. Innovations such as advanced airflow management, custom server design, and regional energy sourcing combine to deliver more performance per watt. For customers, efficient infrastructure means workloads run faster and greener at the same time, proving that environmental efficiency and computational excellence reinforce each other rather than compete. Sustainability extends beyond operations into the supply chain through circular hardware design and responsible sourcing. Google engineers servers with modularity and recyclability in mind, allowing components to be repaired, upgraded, and reused instead of discarded. Metals and materials are sourced ethically, and decommissioned equipment re-enters production loops through refurbishment programs. This circular approach reduces waste, lowers embodied carbon, and supports a more resilient supply ecosystem. For example, a retired data center server might find new life as part of a development cluster after refurbishment. By applying sustainability principles to hardware life cycles, Google demonstrates that environmental responsibility can coexist with rapid technological evolution and global scale. Understanding emission scopes helps organizations measure their complete environmental impact. Scope 1 covers direct emissions from owned sources, such as generators or vehicles. Scope 2 includes indirect emissions from purchased electricity, heating, or cooling. Scope 3 extends further, accounting for all other indirect emissions across the value chain, from supplier manufacturing to customer usage and product disposal. Google reports transparently across all three scopes, recognizing that true sustainability requires accountability beyond operational boundaries. This comprehensive view empowers customers to model their own emissions accurately when using cloud services, promoting shared responsibility across industries and ecosystems. Measurement frameworks and disclosures ensure that sustainability claims are verifiable. Google adheres to globally recognized standards, including the Greenhouse Gas Protocol and Carbon Disclosure Project, to quantify and report emissions. Continuous data collection and third-party audits maintain transparency, while annual sustainability reports detail progress against targets. Cloud customers can access dashboards showing carbon-free energy performance by region, helping them align their workload placement with their environmental objectives. Measurement is the bridge between commitment and credibility. Without it, sustainability remains aspiration. With it, organizations can track progress scientifically, demonstrating integrity to stakeholders and regulators alike. Aligning sustainability with financial outcomes turns environmental goals into business incentives. Energy efficiency lowers operational costs, waste reduction improves margins, and transparent reporting attracts investors and customers who value responsible practices. For instance, adopting sustainable operations can reduce the total cost of ownership by minimizing idle capacity and optimizing storage retention. Additionally, environmental responsibility enhances brand reputation, building trust with both consumers and employees. By linking sustainability metrics with key financial indicators, such as cost savings, risk reduction, and market differentiation, leaders reinforce that green strategies are not charitable side projects, but essential drivers of long-term profitability and resilience. Workload placement and energy profiles give customers an active role in carbon reduction. Google Cloud allows organizations to choose regions where carbon-free energy availability is highest, aligning deployments with environmental goals. Tools like the Carbon Footprint Dashboard show the emissions associated with workloads by geography. For example, running analytics in a region powered predominantly by renewables can significantly reduce a project's overall carbon intensity. These insights turn infrastructure design into an act of stewardship. By choosing greener regions, scheduling workloads intelligently, and monitoring usage patterns, customers contribute directly to global decarbonization while maintaining performance and scalability. Storage policies and data retention practices also play a role in sustainability. Every stored byte consumes energy, so minimizing unnecessary retention reduces both cost and environmental impact. Google Cloud offers multiple storage classes that balance performance and sustainability, automatically transitioning infrequently accessed data to more efficient tiers. Organizations can adopt greener defaults, such as lifecycle rules that delete or archive stale data. For example, logs older than 90 days can move to cold line storage, cutting emissions while retaining compliance. Sustainable storage is less about limitation and more about intentionality, keeping what matters and letting go of what no longer serves business or regulatory needs. Developers contribute to sustainability through efficient code, builds, and deployment practices. Optimized applications consume fewer CPU cycles, perform fewer network calls, and require less infrastructure, directly reducing energy use. Continuous integration pipelines can be configured to run only necessary tests, caching intermediate results to avoid redundant computations. For instance, reusing build artifacts rather than recompiling entire systems reduces compute demand without affecting quality. By embedding sustainability into development culture, organizations make efficiency an integral design goal. Well-written software not only delights users, it respects resources, proving that technical craftsmanship and environmental consciousness are complementary pursuits. Governance ensures that sustainability goals translate into consistent practice. Policies define acceptable energy sources, data retention limits, and vendor standards. Regular sustainability reviews evaluate performance against benchmarks, while accountability mechanisms assign ownership for improvement. For example, sustainability officers or cross-functional committees may oversee cloud usage patterns to ensure alignment with corporate targets. Governance frameworks embed environmental accountability alongside financial and security governance, ensuring sustainability decisions are made deliberately, documented clearly, and revisited frequently. Structured governance keeps sustainability from drifting into aspiration and anchors it firmly in day-to-day operations. Reporting closes the loop by translating progress into visibility and assurance. Dashboards, internal audits, and external disclosures communicate sustainability performance to executives, regulators, investors, and customers. Regular updates demonstrate transparency and reinforce trust. Google Cloud provides reporting tools that visualize carbon-free energy use and efficiency trends over time. For example, teams can track monthly reductions in compute-related emissions after optimizing resource allocation. These reports inform strategy, shape policy, and highlight success stories worth sharing. Transparent communication makes sustainability a shared achievement across teams and stakeholders, strengthening organizational cohesion and accountability. A sustainability roadmap balances near-term wins with long-term commitments. Quick victories, such as migrating to greener regions, reducing idle workloads, or optimizing cooling efficiency, deliver immediate progress. Long-term commitments, like achieving full carbon-free operations or re-engineering supply chains, require sustained investment and innovation. The key is incremental progress measured consistently over time. Roadmaps provide direction, showing how today's choices contribute to tomorrow's achievements. For example, setting yearly reduction targets builds momentum and keeps goals achievable. Sustainable transformation is not a one-time milestone, but a journey shaped by steady, measurable advancement. Sustainability works best when it is embedded, not bolted on. It succeeds when environmental responsibility becomes an invisible part of decision-making, present in design reviews, budgeting discussions, and performance metrics. Google Cloud's approach demonstrates that sustainability and technology progress can move in the same direction, each accelerating the other. By integrating clean energy, efficient operations, and transparent governance, organizations future-proof themselves against both regulatory and environmental uncertainty. True sustainability is not about constraint. It is about continuity, building systems that endure, adapt, and thrive while leaving the world better than they found it. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.